Hello and welcome to this video tutorial presentation on how I can do the serial communication by using 8051's Uart module, which is supporting universal asynchronous reception and transmission. So let us go for creating a project using Keil microcontroller, Keil integrated development environment. So let us say the project is serial communication. uh, I select the microcontroller, so I need to select the microcontroller 8051. So let us go for manufacturer Intel. Microcontroller will be 8051. uh, this is the microcontroller I select. It will ask you to add the startup file initially. Let us neglect that part. Will create your own project. So now here you are expected to type your program. So already I have one program available, so I will be adding that program to my project. So serial tx is the name of the program. So let us initially discuss what this particular program is. So this serial communication program initially starts with the org0000h. This is the assembler directive, telling the assembler that whatever code next is returns, whatever hex code will be formed, that will be loaded in the program memory from the address 00h onwards. Let us go through the program. So initially what I'm doing is I'm loading 20h into the timor register. So when I load 20h into the timor register, this is the format for the timor register. So you'll come to know that this value will be 0010. So and remaining bits, timer 0 bits will be 0. So as it is 0, I'm using timer 1 as a timer, and it is 10 means I'm using timer 1 in mode 2. So mode 2 of the timer 1 is auto reload mode. So in auto reload mode, what you do is that you load some value, into the th, and the th value will get loaded into tl, and with the pulse input. So as I am using timer 1 as a timer, so the pulse input frequency will be oscillator frequency divided by 12. So at that frequency the timer value will go on incrementing. So what I do is uh, timer 1 used in mode 2, which is at what next I use is I load -3 into the th1. This has to do with the baud rate selection. We will see in detail when we will see this scon register format. So scon, I'm loading 40h into the scon register. So what happens when I load 40h into the scon register is this is the register format for the scon, where I load 40h, means this will be 0 1 0 0, and remaining bits will be 0. So this will be 0 1 SMB. This is 0 1. So if it is 0 1, then the mode for the serial communication will be 8-bit UART mode. So baud rate will be variable. So what I'm doing is I want to do 8-bit transmission. A universal asynchronous transmission means one start bit stop bit will get added, and this is the mode 1. So let us go through what the mode 1 is. So mode 1 for the serial communication using this UART module is a variable baud rate. So this is the formula for baud rate. Basic formula is baud rate is equal to 2 raised to s mod divided by 32 into timer 1 overflow rate. And when timer 1 is used in the mode 2, which is auto reload mode, the timer 1 overflow frequency will be oscillator frequency divided by 12. That will be the machine cycle frequency, and that is overflow rate will be 256 minus th1 value, whatever th1 value I load. So for example, if I want to get a baud rate of 9600 and the clock connected is 11.0592 megahertz, so I get that count to be 253. So th1 should be loaded with 253. The hexadecimal equivalent of 253 is fd, as well as the 253 value decimal in the signed arithmetic I can represent it as -3 in decimal. So -3 is also fd. So in our program what we have written is this value is -3. So this corresponds to the generation of the baud rate 9600, and then serial communication baud rate we have selected, which is 9600, and the mode is 8-bit variable baud rate transmission. So we will be transmitting total 10 bits, start bit, 8-bit data, and then stop bit. So then what I'm doing is I'm running the timer, means baud rate generation will start. Next you are doing what you are doing is here, instead of sending character one by one and writing that character in a program, so the length of the program will increase. So what is done is you are creating a what we can say array in the code memory itself, which will be consisting of the characters which I want to set. So this is what is the pointer message, and this pointing to the message Walchan, and then see what last I have written is 0. So our convention will be 0 will be the last character inside the message. So what I do is dptr is pointing to the memory location of the message, means this is the start address of the message. Then what I do is initially I clear accumulator a plus dptr, so still it will be pointing to the starting address. So presently it is pointing to the w. So with the instruction, see the instruction move c, means you move the contents from the code memory. So this w, this is pointing to the w, this will be the address of w, so w will come to the accumulator. Now what you're doing is jump if 0 to down. So I know that 0 will be the last character. So if the character is 0, then you go to the down, and down will be a infinite loop. So if it is not 0, presently it is w, so it is not 0, so you will come here and you will call a subroutine called as trans. So in the trans subroutine, what is written is you move the contents of accumulator to the sbuf. So we move the w character ASCII value of that into the sbuf register. So as soon as you load something in the sbuf register, the data will get transmitted serially onto the txd pin. Then there is one provision in 8051. How you will come to know that your transmission is over? So whenever the transmission is over, the ti flag bit is set. So here what I am doing is I am polling for that ti flag bit. So if the ti flag bit is not set, means transmission is going on, just poll for that. And if it is transmission is completed, ti will be set, you will come outside the loop. So what I do is I clear ti, and simultaneously here itself what I am doing, I am incrementing dptr, so that I will be pointing to the next character. So I will be pointing to I. So I will come to the main program, again this is pointing to I, so I will come to the accumulator, and again it is not 0, so you will transmit I. So walchan, w a l c h a n d, everything will come to the accumulator, they will send. So after transmission of d, next character will be dptr will be pointing to 0. So when you come point to 0, when you come here, the 0 will go to the accumulator. Jump if 0, whether 0 is equal to 0, yes, so you'll go to the down routine, and the down routine what you have done is you have written a infinite loop, so that here what I can be what your transmission is over. So what you can do is you can create a hex file for your project, and then you can check. There is one option, go for debugging, and just I want to check where my message is getting stored. So in view, there is one option, you can view memory window, and just in the memory window what you can do is you can go for, you can select the address which you want to view. So go to the memory window, and then in the code memory, just you type c and then 000 H. So all initial memory locations you want to view, so you can view that locations, and you can check in your program. What you have done is add the address, let us say 23 onwards you have stored your message, so you can view that part also. So from the address 23 onwards, you can find this is 20, 21, 22, 23. So this is the ASCII value of w. So this is ASCII value, what we can say hexadecimal equivalent of ASCII value of a, right? So this is what we can say, w a l c h a and d, and next is what, 0. Okay, this is how the message gets stored. Now I want to check really my communication is taking place or not. So here I cannot come to know whether my transmission is successful or not. So for that I will take the help of Proteus. So when your hex file is ready, so what I can do is I can create the hex file also, this simple Proteus design file, where what I have done is microcontroller is connected to the virtual terminal, which is capable of receiving the data or transmitting the data. Presently I am using this virtual terminal as a receiver. What next is the txd of microcontroller is connected rxd here, rxd is connected to txd, and then request to send and clear to send, these signals I have shorted. Okay, so now what next I have to do is I have to load the hex file. So prior to that, what has to be done is you have to create the hex file for your project. So go to the target, enable the creation of the hex file. So in the output, enable the create hex file option, and again rebuild your project. So what you can do is after this you will get one message that 0 error, 0 warning, fine, and then creating hex file. So you can check the project folder you can find that there is a file called as serial communication.hex. so in the proteus I will take the help of that particular file, serial communication.hex. okay, so that file path is been provided. Remember, this is a simulation, so for the simulation purpose we have not collected clock, so just here I am mentioning what that clock frequency is. okay, practically you have to connect the clock, that reset connection is to be there, that EA bar connection has to be there. okay, so just for simulation purpose I have loaded the program. It is as if I have burned the program into the real microcontroller, and let us check the results of the simulation. so see what message I am getting is the Walchan. so what message you are transmitting, same message you are getting. okay, so instead of this, if I change the message, let us say instead of Walchan, let us make the message hello textc, whatever message you want to have. again what I do is I create the hex file, and then I go to the simulation part. Previous simulation I stop, I run the simulation again. See what message I get, hello textc. but remember, to get this message what provision has to be made is the clock frequency, because for the calculations our assumption was clock frequency is 11.0592. by mistake, if it is 12 megahertz, by default usually it is 12 megahertz. let us see what happens. so if I run my code, the transmission will take place, but see, this is how the transmission is taking place. So baud rates are not matching. Fine. so to our matching baud rate, the clock should be properly selected. so what I have to do is I have to select the clock frequency which is used for the calculation, and that is more specifically 11.0592 megahertz. so if I select this particular clock frequency, and now again if I run this code, you are going to get the output. okay, so if I view that virtual terminals, this is the message you are going to get. so this is how you can do the serial transmission by using the Uart module of the peak microcontroller. with the help of simple ASM file return, you can transmit the data serially, and that data can be viewed onto the virtual terminal. okay, thank you.